Hello everyone and welcome. This is JC and you are watching a SkyTech presentation of Blazor components in depth. This is part 1 of 2. Now let's see the agenda for this presentation. The items from 1 to 8 will be covered in part 1 and they are: what is a component, some component coding conventions, component namespaces, component static assets, component layered architecture, component routing and route parameters, setting component child content, and component references. The items from 9 to 16 will be covered in part 2. So let's begin with the first item on the agenda. What is a component? Components are the building blocks of Blazor apps. Let's say this in action. I open my Visual Studio 2019. Note that the version of Visual Studio on Windows 10 should be equal to or later than 16.66.0 or 8.6.0 for Mac to work with Blazor Webassembly inbuilt project templates. I land up in the Getting Started page, in which I click on Create a New Project. Then I'm routed to the project template selection page, where I search for the Blazor template in the search box, and then I select the Blazor template and then click Next. Then I'm routed to the project configuration page, where I give my project an appropriate name, Blazor Spa in my case, and set the folder location. Then I click on Create. Finally, I reach the last step of the project creation. Here I select the Blazor Webassembly app option. Two more things I need to mention. For this project, I am leaving the authentication to no authentication, as I am going to deal with it in a separate video. Also, I have left ESP.NET Core hosted option unchecked, as I am going to create a Blazor Spark project with no server-side code. I go ahead and click on Create. Done. My project creation is complete. Let's go to the pages and shared folders. Let's expand them. We see that components reside in both these folders. Now, why these two folders? The main reason is that components that produce web pages usually reside in the pages folder. Non-page components, for example, main layout, nav menu, are actually shareable components, and that's why they reside in the shared folder. We can also place the components in a custom folder added to the project. We will talk more about it later on in this video when discussing component namespaces. So here's our observation number 1. The components that reside in the pages or in the shared folders, they all begin with an uppercase character. Can you see them? Counter, fetch data, index, main layout, nav menu, survey prompt. Now, this is by design and not as a matter of choice. Now here's observation number 2. I click on fetch data and see that a component is made up of directives like @page, @inject, HTML markups like h1, p, table, conditional statements like if, processing loops, for each, code blocks. Let me minimize this. Code blocks, C# statements, models, etc. This leads us to the definition of a component, which is a component is a self-contained chunk of user interface. It includes HTML markup, which defines the component UI, processing logic, example given loops, conditionals, expressions, UI events, example given click event, mouse events, etc., page data models, etc. Now, here is observation number 3. Component classes have, if you just have a look at pages and the shared folder, component classes have a .razor extension. Such a file is technically referred to as a razor component. Now, the embedded C# code within the component is called razor. Blazor uses razor components to render the UI. .razor components are similar to .chtml views in that they both leverage razor and have similar syntax. But the key difference between them is views are dependent on a controller, whereas components are not. To summarize, a component is a self-contained chunk of user interface. Example of components in Blazor are a page, a dialog, a form, a grid, a sidebar, a navbar, a dropdown, a text box, a button, a card, a header, a footer. All are components. Advantages of a component are it is flexible and lightweight, it can be nested, it can be reused, therefore we can write maintainable code, can be shared among projects. This brings us to the end of our presentation of item 1 of the agenda. Item number 2 in our agenda is component coding conventions. Now, here is the first rule. Let us visit pages and shared folders again, and we have already discussed it earlier that all the names of the components start with an uppercase character. I repeat, it is a matter of design and not as a matter of choice. Now let's see what happens if we actually create a component that starts with a lowercase character. Let's try to run the application now. You see, we get an error. And what's the error? It's clearly mentioned that component hello world starts with a lowercase character. Now here is the second rule. I open the pages folder, click on counter, and we have a code block here. Let me create another code block. Let me move this piece of code from the first code block to the new code block. Let's run the app. It works the same. Therefore, rule 2 is if you need to organize your code, you can create multiple code blocks. So multiple code blocks are permissible in Blazor. Any component member variable, for example, current count in this case, can be rendered as a part of the component's rendering logic using C# expressions that start with @ as you see here @current count. So this is how we can actually render any variable in the HTML by just prepending @. This was rule number 3. So this brings us to the end of our presentation of item number 2 on the agenda. The next item in the agenda is component namespaces. Typically, a component's namespace is derived from the app's root namespace and the component's location folder within the app. Let me create a new component hello world within the pages folder to demonstrate it. Now let me use this component within the counter component. Now if the app's root namespace is Blazor spa, as in my case, and the hello world component resides in the pages folder, then the hello world component's namespace is Blazor spa.pages. The fully qualified type name of the component is Blazor spa.pages.hello world. As you can see here, if you hover the mouse on the component type, Blazor spa.pages.hello world. Now this was in the case of a component that is residing in the default pages folder. Now for custom folders that hold components, we need to do some extra steps like add a using statement to the parents component or to the apps underscore imports.razor file. This file imports.razor. Now let us see this in action. Let us create a new custom folder first. Oh, I'm sorry. Now let us create another component within this custom pages folder. Let's call it test component. Now let us try to use this component in the counter component. As you can see that we are getting an error. This is because the component is residing in a custom folder and not in the default pages or shared folder. Now to correct this issue, here is what we need to do. So one of the options is we can write the fully qualified namespace for this particular component and this issue will be resolved. Okay. So that's the first option to resolve this issue whenever a component is residing within a custom folders. Now the second option is we can add a using statement to the parent component. So here the parent component is the counter component. So we can add at the rate using statement, at the rate using statement, and then you can see that it works. Now there might be a scenario where we need to add this test component into 10 different other components. Say for example fetch data, say hello world, index razor, which means that we need to add at the rate using Blazor spa.custom-pages statement in all the components wherever this test.component is going to be called. Now this is basically repetition of code. So what we can do is in this case we can actually put it in a global location which is the imports.razor. So I removed it from here and then I put it in here. Look, the error is gone. So I repeat, for custom folders that hold components, we need to add a using statement to the parent components or to the apps underscore imports.razor file. This brings us to the end of item number 3 presentation on component namespaces. Item number 4 is about the static assets location and use in a Blazor app. Here are a couple of things that we need to know in this regard. First, Blazor follows the convention of ASP.NET Core apps by placing static assets under the project's web root, that is the www root folder. Second, it is the base path for public static resource files such as style sheets, JavaScript, images. Third, by default, static files are served only from the web root directory and its subdirectories. Fourth, Razor components do not support tilde/ notation. Therefore, for path declaration, only use / notation. Let us drop an image in the web root. Now let us use this image in the test data component that we had created earlier. The test component. Let us run the code and see whether the image is being rendered. Yes, it is. So as you can see that the default folder is the web root and the download.png is at the root of the web root. So there's no need to mention www root folder. All that we do is straight away reference the path of the file and it works. Now here's the most important thing that we want you to take note of. Never forget this. Never use tilde, which is a normal convention when we work with .cs HTML files. So never use tilde sign in a Blazor component because it won't work. So let's see whether it works or not. It didn't, because the path of the image could not be resolved, as because we have actually put the tilde/ notation. This brings us to the end of the presentation of item number 4 on the agenda. Item number 5 is about components inside components. Components can include other components by declaring them using HTML element syntax. Remember, we have already seen it earlier that when we rendered an instance of test component within counter component during item number 2 presentation on component coding conventions. Let's open the counter component. Here, this is what we added when we were actually demonstrating on item number 2. Now the markup for using a component looks like a HTML tag where the name of the tag is the component type. Test component markup renders a test component instance. This brings us to the end of presentation of item number 5. Item number 6 is about component routing and route parameters. Let us open the counter component. We see @page directive with a router template. Let us see this router template in action. I run the app and hit the router template in the browser. It works. Let me change the route and hit it in the browser again. It works. So we can see that routing in Blazor is achieved by providing a route template to each accessible component in the app. When a Razor file with an @page directive is compiled, the generated class is given a route attribute specifying the route template. At runtime, the router looks for component classes with a route attribute and renders whichever component has a route template that matches the requested URL. That's how it works. So that was all about routing, and now let's have a look at the route parameters. Components can have component parameters which are defined using public properties on the component class with the parameter attribute. Let us write another page directive and another route template with a route parameter. This is how we write a route parameter, which starts within brackets. Now you might be wondering why we have two @page directives. The reason is that Optional parameters aren't supported, so two @page directives are applied here. The first permits navigation to the component without a parameter. The second @page directive receives the starting number route parameter and assigns the value to the component property, which I'm going to add now. So let me add a component property. Now remember, the name of the component property must be same as the route parameter. Now let us add a lifecycle hook on init. Now let us initialize the variable current count with the value that has been passed through the route parameter. Let's run the app and let's see how this works. Oops, we have an error. Let's see what's the error. I see that the error was a specified cast is not valid. So there is a casting error, and I know exactly the reason why. Actually, if you notice, route parameter does not have any data type, whereas the component parameter has a data type of int. So that's why there is a cast error from a string to an int. So let's explicitly, mention the data type as int. And now let's check it. It works. So you can see that we have passed the value 10 in the route parameter as the starting number, and this is shown here. So if I add click, so the increment will be done from the starting number only. So to summarize, components can receive route parameters from the route template provided in the @page directive. The router uses route parameters to populate the corresponding component parameters. This was all about the item number 6. Item number 7 on the agenda is templating components with render fragments. So far, we have created components that generate 100% of their rendered output. But components are not that simple all the time. Sometimes the HTML output generation responsibility as well as the event trigger responsibility of a component can be delegated to a subcomponent. Let's see it in action. Let us create a child component of the counter component and name it counter child. Now let's add this component counter child as a subcomponent in the counter component. Now let's try to set a child content. Let's run this and let's see what happens. As expected, we have an error. Now let's see what is the error. Now it says that unhandled exception rendering component object of type this does not have a property matching the name child content. Now this is most important. It's saying that the counter child component doesn't have a property matching the name child content. So the compiler is expecting a component property named content child within the counter child component. Now let's go and add it. Now let's create a view for this. Let's render it and check the output. It works. You can see that the content is appearing within a red box, which is actually the CSS that I applied in the child component. So the content is being rendered in the child component. Therefore, we can see that every Blazor component has a reserved component property, which is child content, and the type of the child content being render fragment. And this reserved property is being used whenever we need to pass some content from a parent content to a child content. Blazor also allows you to define a parameter of type event callback, which can be used to hook a method of the parent component. Let's say it. Let's call this from a button component. Now in the counter component, that is the parent component, we need to add this callback. Now let's see it in action. So I know that if I click here, the counter will get incremented. Now what I'll do is I will click here, which is the child component, and I will check whether the counter is still getting incremented. Yes, it does. Therefore, what we just saw was that the HTML output generation responsibility as well as the event trigger responsibility of a component can be delegated to a subcomponent. The last item in this video is component references. In the previous item presentation, we learned how we can invoke methods of a parent component from a child component. Now, we will learn how we can invoke methods of a child component from a parent component. Let's say this in action. Let me open index component and let me make a change here. Now we require a reference to this counter component to access it within the code block. For this, we should decorate the component with @ref as follows. Now let us try to access the methods of this component from the parent component, that is the index component, in the code block. We cannot access the increment method of the counter component, and that's because here the scope of the method is private. So let's make it public. Now let's go back to the index increment counter. Yes, we can access it now. Now let's add a button element to trigger this method. Done. Now let's run and see the results. Now the expected result should be, if I click on the button in the parent component, then the counter in the child component should be implemented. Let's see whether it is happening or not. I click on the button in the parent component, click, 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 but nothing happens. But we don't see any error either. If you check the console, you will see that there is no error. So, what exactly happened? Are we missing something? Don't lose heart. Let us actually try to put a debugger and see what exactly is happening. Let me go to the counter component and let's see whether the parent button click is at all hitting the child component's method. Yeah, so this is the method of the parent component. Yes, it does. It is indeed, you see the current count in 6. If I click here and I go and inspect the increment count method of the child component, I see that the increment has been done. So internally it's working. So what is the reason why actually the UI is not being refreshed? Couple of things to explain. First, when we use an instance of a component within another component, the parent component renders first and then the parent component renders its child. In this case, index component renders first and then the child component, which is the counter component, is rendered. Second, when I call a method on a .NET object, which is counter component object in this case, Blazor isn't involved. Yes, I repeat, Blazor isn't involved. That's entirely inside my code. Hence, DOM is unaware of any state change, hence no UI re-render happens. This is exactly what is happening in this case. Click here, even though internally we can see that the methods are getting hit, but the UI is not getting rendered. Therefore, the state change method must be called to get the DOM to register these changes explicitly. To trigger the state has changed method for the child component, let us do this. Let's go to the counter component and now let's add an event callback parameter. And let's give it a name, index event. So now whenever we will click on the button in the parent component, this event in the child component would be fired. Now let me just put a comment. It So it triggers the state has changed method whenever the component instance is accessed from parent. Okay. So now let's go to the index component and then add this callback over there. Let's bind it to a method in the parent component. Let us leave it empty because we just want to trigger the event in the child component, so we don't want to perform any other action, so let's leave it empty. Now let's check. Yes, it works. So now we can access and invoke a method of a child component from a parent component, like we see here. So what is really happening under the hood here is the state has changed method is automatically called after the callback UI event is triggered. After clicking of the button element, this button, the click event is raised and the state has changed method is automatically called to notify the child component that its state has changed and it should re-render. That is what is happening here. So that's it for this video. I will be coming back with more videos on Blazor Webassembly architecture, debugging, super features, state management, JavaScript interrupt, authentication, globalization and localization, and so on. If these interests you, do not forget to hit the subscribe button to stay tuned. Thank you for watching.